Hello everyone. Our next topic for the A-level chemistry is Introduction to Organic Chemistry. Introduction to Organic Chemistry. What is organic chemistry? Organic chemistry is defined as the chemistry of hydrocarbons and their derivatives. This is called as organic chemistry, and most important in case of to distinguish between organic chemistry and some other, for example inorganic chemistry, the most important feature is all the compounds that can burn, all those are termed as organic in nature, definitely, and those compounds, those substances that can be ignited, those are also called as a part of organic chemistry. Now, for example, hydrocarbon, those compounds which are made by only carbon and hydrogen, those are called as hydrocarbon. The parent hydrocarbons are alkanes with general formula CnH2n+2. Alkanes, the first member methane, ethane, propane, butane, all these are so on. These are also called as hydrocarbons. This is methane, this is propene, this is butane, this is chloromethane, this is propanol. These are the compounds which are derivatives, can be derived from the hydrocarbons. These are derivatives, and all these are the hydrocarbon. That's why the chemistry of hydrocarbon and their derivative is called as organic chemistry. Now, there are so many different types of formulas are present in organic chemistry. The first type is empirical formula. Empirical formula. Those formulas which shows simplest ratio between atoms, those are called as empirical formula. For example, if we have this a formula C3H6, this is formula of propene. Now, the ratio between atoms is 3:6, and this can be simplified by dividing both of these digits by 3. 1:2. It means that the simplest ratio of carbon and hydrogen is 1:2. On the basis of this, I can write CH2 formula for the propene. Now, this formula which will show the simplest ratio between atoms of a compound, that is called as empirical formula. The formula which shows the simplest ratio between atoms. Similarly, if I take the example of glucose C6H12O6, now the atomic ratio will become 6:12:6, means 1:2:1. On the basis of this simplest ratio, we can write CH2O, simplest empirical formula for the glucose. But the empirical formula cannot explain the nature of the chemical compound. For example, if I take ethanoic acid CH3COOH, if I combine all these atoms, I can write this formula just like this: C2, then H4. How many oxygens are there? Oxygens are 2. It means that the atomic ratio is 2:4:2. If we simplify this, 1:2:1. Again, the formula will become for the ethanoic acid similar to that of glucose. It means that both of these empirical formulas are same, but the empirical formula cannot explain either it is a glucose or either it is an ethanoic acid. The formula which shows the simplest ratio between atoms is called as empirical formula. But if the atomic ratio is already simplified, for example in case of methane, the ratio between two atoms is 1:4. As the atomic ratio of one element, carbon, is already simplified, that cannot be further simplified. That's why in this case, this formula CH4 is the empirical formula for methane. The same is the empirical formula for methane. Now, molecular formula, the formula which shows the actual number of atoms present in a molecule, that is called as the molecular formula. For example, the molecular formula of propene is C3H6. This is the empirical formula. The molecular formula for glucose is C6H12O6, not CH2O. This is the empirical formula for glucose. The molecular formula for ethanoic acid is C2H4O2, but not CH2O. This is the molecular formula for the ethanoic acid. But in case of methane, as the formula CH4 is indicating the total number of atoms present in a molecule, that's why the same formula is the molecular formula for methane. It means that in case of methane, the same is empirical formula and the same is the molecular formula. How these formulas are interrelated with one another, we know that molecular formula can be obtained by multiplying n by empirical formula. If we multiply empirical formula with the value of n, which is obtained by the division of molar mass by the empirical formula mass, we can easily calculate the molecular formula of the substance. Now, next is the structural formula. Structural formula. Now, we know that the formula for butane is C4H10. This is the molecular formula. If we want to write down the structural formula, then each carbon atom will be represented differently. CH3, CH2, CH2 and CH3. This is the structural formula. Structural formula which represent each carbon atom and a light hydrogen atom as a single separate unit. This is structural formula for butane. Now, this can also be written as CH3, CH or CH3 and CH3. This is also a structural formula of isobutane. This is the butane, this is the isobutane. Now, whenever we will represent all the carbon atom along with their alike hydrogen atom as a single separate unit, then those formulas will be termed as structural formulas. Now, next is displayed formulas. Displayed. For example, if I have to represent the displayed formula of butane, definitely I will show all bond present into the butane and I will represent all atoms separated in the bonded form. Each bond will be represented separately. That's why such type of formula which will represent all type of bonds separately, those are called as displayed formula. Displayed formula. For example, if I want to write down the displayed formula of propanol, CH3, C3H7OH. If I want to represent this, I will represent all these carbons separately. Then all valencies of carbon are satisfied by hydrogen, and then one valency is represented as OH group. But if I represent here OH combined form, then the displayed formula will be considered incorrect. In case of displayed formula, we have to represent all the bonds separately. That's why this will be called as a displayed formula. Now next is the skeletal formula. Skeletal formula. Now we know that in case of methane, CH4, its geometry is tetrahedral in nature. Carbon is at the center, and then all four hydrogen atoms are arranged towards the four corners of a regular tetrahedron having angle 109.5. This tetrahedral geometry is created by the carbon when carbon is forming four separate bonds. Now, if we look at this molecule, all these three carbons are formulating single covalent bond. As each carbon will behave as a tetrahedral structure, as I have represented here, it is not possible the development of a straight chain carbon atom. What will happen? Whenever, if for example, this hydrogen will make bond with any other carbon atom, definitely carbon will come here in front of this. Then that carbon atom, if want to develop a covalent bond with another carbon atom, definitely that carbon atom might go up in this manner. So a zigzag structure we will obtain, and as a result we will show as a skeletal formula. But whenever we have to represent the skeletal formula, we will just only use a line, and at each corner a carbon atom will be present and a hydrogen atom will not be represented. For example, if I want to write this skeletal formula of this propanol, definitely I will represent just like this, and on one side I will represent OH as a functional group. Now this is important, that functional will be represented separately and all atoms present in the functional group will be represented. Now this is the skeletal formula of propanol. If I want to draw the structural formula of, for example, butane, I will represent just like this. This is a formula of butane. Now if I want to represent skeletal formula of one butene, I can draw a double bond on one side, one butene. If I want to represent the skeletal formula of two butene, then how I can represent? I will draw double bond here. This will be the formula of 2-butene. In this manner, we will assume in skeletal formula that at each corner carbon is present. One carbon, second carbon, third carbon, and fourth carbon. Now, rest of the valency of all these carbons are understood, that these are satisfied by hydrogen. No need to represent all these. We have to just mention that the carbon is present at the corner. Definitely that will represent, only the carbon atom at the corner of each bend. Now, next is the wedge-shaped formula. For example, if I want to represent here these three carbon atoms, if the one hydrogen is coming towards us, definitely we will show it in the form of wedge. The hydrogen which is going away from us, that will be represented by a dotted line. And the hydrogen which is going away from us, that can be represented in this manner. It means that hydrogen is moving away from us. Now this is called as a wedge shape. For example, if I represent this hydrogen in this manner, it means that the hydrogen is out of the plane. And if the hydrogen is represented just like only dotted line, it means that the hydrogen is inside the plane. In this manner, the formula can, a skeletal formula can also be represented in the form of wedge-shaped formula of the different substances. These are the different types of formulas that will be frequently used in the organic chemistry. I hope you understood all of these concepts of the type of formula. Please comment, share, like and subscribe the channel for the next upcoming videos. I thank you all.